Okay, we're going to look at solving linear inequalities. Um, Here it is right here. Say we're asked to solve 2x plus 2 is less than or equal to 1. First, this inequality thing, we get confused with these arrows, these inequality symbols. It reads 2x plus 2 is less than or equal to 1. What you do is you start from one side, say the left side. If it's closed like that, like a point, it means less than. If it's open, say you come from the right side, see it's open, it means 1 is greater than or equal to 2x plus 2. 2x plus 2 is less than or equal to 1. That's how you read the inequality. Well, you treat it just like an equation. You do just about the same thing. You want to get the x's by themselves, so you take away 2 from both sides. 1 minus 2 is negative 1. And then you want to get the x by itself, so you divide both sides by 2, and you get x is less than or equal to minus 1. See, it's closed. X is less than or equal to minus 1/2, sorry. So, when the arrow's got a line underneath to it, it means less than or equal. And if you are asked to illustrate it on a number line, what you do is just put minus 1/2 on the number line. Maybe you could put a little 0 there to show that it's less than 0. You label minus 1/2. And if it's equal, you fill in a solid circle and then an arrow showing that it goes to infinity to the left. All the real numbers less than minus 1/2. That's how you show it on your number line. Okay, so let's look at another one. Here we have 4q plus 3 is less than 2 times q plus 3. This is greater than 4q plus 3. 4q plus 3 is less than because it's closed, you see. Okay, multiply out the bracket. 2 times q is 2q. 2 times 3 is 6. Subtract 2q and subtract 3 from both sides. 4q minus 2q is 2q. 6 minus 3 is 3. Divide both sides by 2, and you get q is less than 3/2. Now, there's no line underneath here, so it's not equal to it. And when you illustrate it on a number line, you go to 3/2, which is more than 0, and it's less than, so it's everything to the left, but it doesn't equal 3/2, so you put a circle with nothing in it. So when the arrow has no line underneath, you leave the circle open like that. Okay, let's take a look at this one. Hey, this one's got 2 inequalities. It's the x plus 3 is less than 8. See how it's closed as we move this way? But x plus 3 is greater than or equal to 5. Okay, well, we still do it like an equation, but we treat all 3 parts. We do the same thing to all 3. We'd like to get the x by itself, so we take away 3 from plus 3. We take away 3 from 8. And we take away 3 from 5, and you end up with x is less than 5, but greater than 2. Well, when you put that on a number line, there's 5, everything less than 5, and where x is greater than or equal to 2. Well, you make it in solid. So when you have 2 arrows like this, then it's a segment less than 5, but greater than or equal to 2. It's actually the intersection of 2 sets, everything less than 5, and everything greater than or equal to 2. Less than 5, x is greater than or equal to 2. See, like that? When it's open, it's greater than. When it's closed, it's less than. Okay, and there's one more thing that's really important, is this sort of thing here. There's something happens when you divide by a negative. If I have negative 5 is less than 10, well, if that's true, if I divided both sides by negative 5, I get negative 5 divided by negative 5 is positive 1. 10 divided by negative 5 is negative 2. And now it says 1 is less than negative 2. Ooh, but that's crazy. That's not true. The only way we can make this true is to change the direction of this arrow, and then it's true. Okay, so we all have to change the direction of that arrow to make it true. So when you've got ever a negative 5x is less than 10, if you ever divide both sides by a negative, you got to remember to change the direction of the inequality. Otherwise, you'll end up with something like this, which is crazy. 1 is less than -2, and that's just not true. We've got a whole bunch of questions to work on and memos to go along with it. Hopefully the video helps. I hope it helps. Okay.